This next adjective is a good one for our intuition, and that is normal. A normal vector, or normal is an adjective to describe a vector. We call a vector normal if its norm is 1. So notice on the handout it says u inner product with itself is 1. Remember that u inner product with itself is actually the norm of u squared. But if the square of something is 1, then that thing is also has norm 1. So if a vector has norm 1, we call it normal. We also call those unit vectors. In other classes that you've taken, you might have seen I hat, J hat, K hat, or in other words, just vectors with a hat over them. We put a hat over vectors if their norm is 1, and we like unit vectors a lot for geometry's sake. I have a good picture to talk about this here. If you have a vector v, then you can take that vector v, and it has a norm. Norm, remember, is the size or the magnitude of v. If you divide by the size, v over v, then you should, for yourself, work out what this is. Use the properties of norms. Remember, if that positive homogeneity property says that this denominator, being a scalar, it's a number the size of v, can actually come outside. And so you should see this expression here simplifies. Now, v hat would be a vector in the same direction as v, because if you just divide it by its own norm, you don't change the direction, you're just scaling. Remember, this is a scaling thing in here. And so you get this result that is v hat, that is in the exact direction of v, but has length 1. And this is a very nice thing in geometry, to be able to take a vector and decompose it into what we call its magnitude, the length, and its direction. And the normal vector, or the unit vector, v hat, tells us everything about the direction of v without worrying about the size. Just like the size of a vector, the norm of a vector tells us everything about the magnitude, but nothing about its direction. And so there's this nice, what we call the polar decomposition of a vector v. Any vector v can be written as a magnitude times the direction. So this is like the size of v times something that's normal, or size 1, and anything times 1 does not change the magnitude, and a vector times a scalar does not change its direction. This is so nice to be able to do with vectors. We use this in the proof of the projection theorem later on in the handout, but you'll probably use this a lot as you work through this chapter.